Math 2415, Calculus 3, Section 13.5, Curl and Divergence, video 5 of 6. First off, my apologies. I think in the previous video, it incorrectly said video 5 of 6, and I may have incorrectly said video 5 of 6. It was video 4 of 6, as should have been described in the description of the video below. Well, in the previous video, that is. But this is video 5 out of 6. And in this one, we're just going to state a theorem without proof. The proof is pretty easy. You just have to chase down definitions. But if f's component functions have continuous second-order partial derivatives, then the divergence of the curl of f is equal to 0. If you're looking in the textbook, it's on page 792, but it is a very short proof and relies 100% on the fact that mixed partial derivatives are equal, and therefore their difference is 0. But how can we use this? Well, sometimes you might need to answer the question, are you the curl of something? Are you as a vector field the curl of another vector field? We're going to show that this vector field is not. The vector field f of xyz is equal to this guy again. First component is xy, second component is xyz, third component is negative y squared. We're going to show it's not the curl of another vector field. Now, how do you show something is not true? Or what's one way to prove things? One way to prove things is to prove it by contradiction. A proof by contradiction basically means you assume something, usually the opposite of what you want to show, and then you arrive at a contradiction. Assuming all of your steps were logical, the only place you could have messed up was your assumption to begin with. So, assume something, arrive at a contradiction, conclude that your assumption was wrong. So to show that f is not the curl of another vector field, we're going to start by assuming it is. Assume that f is equal to the curl of G for some vector field G. Now, if all the steps we make next are correct and what we arrive at is a contradiction, then that means the only mistake we made was at the beginning, that our assumption was wrong. Now, if f is equal to some curl of G, then we know that if we take the divergence of both sides, divergence of f equals the divergence of the curl of G. Well, we just had a theorem that said that would be 0, assuming that your second partial derivatives are continuous. Well, let's work under the assumption right now that they are. But our divergence, and we've calculated this vector field's divergence in the previous video. Partial with respect to x is z, partial with respect to y is xz, partial with respect to z is 0. But the divergence f was not equal to 0. And we just arrived at a contradiction because we concluded that the divergence is 0 and simultaneously concluded that it's not. Those things can't be true at the same time. We've arrived at a contradiction. The symbol for contradiction in logic is two arrows crashing into each other. Contradiction. It's like you've got two opposing sides butting heads. I'm equal to 0, I'm not equal to 0. We can't both be true at the same time, even though we just concluded that they are, which means we made a mistake in our initial assumption. Therefore, our assumption was wrong, and f is not equal to the curl of G for some vector field G. It's a pretty nice way to prove things. And really, outside of math, you can nail a lot of people and say, you know, what you're saying is wrong and here's why. Let's assume it's right. Logic, contradiction. Only mistake was the assumption, therefore you're wrong. Look for opportunities to try it. It's pretty cool when you can pull it off. All right, so not a whole lot going there, besides the fact that with this theorem, we can show that some vector fields are not curls of others by showing that their divergence isn't identically 0. That's pretty short. One more video. The last video is more comment than let's do stuff, so it'll be short also.